Hello everyone, this is chapter 9, problems. We are going to solve some of these questions. In these problems, we have 24 questions. First 4 questions are longer form, and after that, rest of it, about 20 questions, is multiple choice. So in this part, I'm going to go over questions 5, 6, 7, 8, 9, 10, and 11. That's a lot, but we'll be fine. Alright, let's get started. So we're going to question number 5. Okay, so let's read this question. A producer is hiring 20 units of labor. Okay, I just love to write down everything. And 6 units of capital. Okay, this is called bundle A. Bundle A. Okay, the price of labor is, which is wage rate, $10. Price of capital rental rate is $2 at A. Marginal products of labor and marginal products of capital, both of them are 20 units. That means the last unit of labor and capital actually contributed the same. Beginning at point A, the marginal, if the producer increases labor by 1 unit, decrease capital by 1 unit. So we're increasing labor to 21, right? So cost is going to increase by the wage rate. So cost increased by $10. And when you fire capital, so decrease the capital from 6 to 5, cost will go down by $2. So it's negative $2. So the cost is increasing for sure by $8. So cost never remains constant. A and B are wrong. So I know cost increases by $8, okay? And then output remains constant. So output is remaining constant. Why? Because marginal product of each unit of worker and capital is the same. So when you hire 1 more labor, you're going to produce 20 more. When you fire a capital or reduce your capital, you're going to produce 20 less. So output, no change. Okay, let's go see question number 6. Same question, okay? So blah, 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 right? Everything's the same. So the producer is using the optimal combination of capital and labor, should use more labor, less capital, should use more capital, less labor, cannot determine from the information. So I'm going to answer it here. So what we're looking at is the dollars spent by, $1 spent on labor or capital. How much output is this bringing me? Okay, I'm just making some space here so I can write down. Hold on. All right. So, okay. So how to solve this question? Okay, so it's very easy. We're going to look at marginal product of labor divided by wage rate. Okay, so this is the marginal product per dollar spent. So $20 units, I apologize, wage rate was $10. Okay, we're comparing this marginal product of capital per dollar spent. Okay, marginal product of capital is 20, but capital's price is $2. So this is, right, this is 10, this is 2. So in English, marginal product capital divided by R is greater than marginal product of labor divided by wage rate. So in English translation, folks, the last dollar spent on labor brings you 2 units, which is less than last dollar spent on capital, which brings me 10 units. Oh my gosh. So if I have only $1, if I put it on capital, I'm going to get 10 units of output. If I put it on labor, I'm just going to get 2 units. Therefore, you should use more capital and less labor. It's this easy. Question 7. Okay, this is a knowledge question. The expansion path shows the cost minimizing input choices change as firm's output level changes, right? So expansion path, boom, I'm trying to produce this. Maybe I'm trying to produce this right here. So expansion path is a path that shows cost minimizing input choices. We have labor and capital here. Capital, labor. Okay. Question number 8. All right, so this is a very common question. And once this question comes, don't be scared. You have all the information you need on this question. Refer to the following figure. Price of capital is $50 per unit. I love to write down everything. R is $50. Okay. What's the price per unit of labor? It's asking me wages. You can be like, Dr. G, how can I find this? Very, very easy. Grab any of these budget lines. Any of these budget lines. It doesn't matter. Okay. Grab any of these. I'm going to grab this one. Okay. This budget line. Alright, so if you remember the budget line general form, it is wage times labor, total cost spent on labor, plus rental rate times capital. This needs to be equal to the cost, okay? And if you reorganize this, it's going to look like K equals, right, C over R, or C times 1 over R, minus W over RL. We are just rearranging. This is Y. This guy is X. Alright, so, and what about these intercepts? Remember, so we have capital, labor. This is total cost of producing this line is C, some dollar amount, divided by wage rate. So total cost of $1,000, right? Total cost divided by wage rate. This is the X-intercept, and this is the total cost divided by rental rate, Y-intercept. So this 250 is total cost divided by wage rate, and this 100 is total cost divided by rental rate. Okay, so I am actually going to do something super interesting. Okay, I'm going to use this information, all right? So I know C, okay, I can't use that one, but I'm going to use it in the future. So I'm going to use this one. So C over R is equal to 100 units. C, total cost over rental rate, is equal to $100. Sorry, units, I apologize. So if I can find C here, right, I know R. If I can find C here, then I can use it here because I know C over W has to be equal to 250. Okay, I'm just going to use it. Use the C I found here, total cost, and get W information. All right, so I'm just solving some equations. All right, so R is 50. All right, C is equal to 100 times R, which is 50. This is $5,000. Okay, total cost is $5,000. That's really cool because C over, right, W here, I know that it has to be equal to 250. So I know C is equal to $5,000. We just found it, right? So W has to be 5,000. You can exchange the places of these two. 5,000 divided by 250. So that's going to be $20 is the correct answer. So what did we do here? Number one, we use the information about the intercept formula. So for the labor intercept, it's total cost of production, whatever this line is, divided by wage rate, and Y-intercept is total cost divided by rental rate. I know the rental rate. I know this intercept was 100 units of capital. This is 250 units of capital. I know this equality. I got the C from here, plugged in here, and solved it for my wage rate. Okay, so this is the only, and you can do the same thing for these points as well. It doesn't matter, just pick a budget line. Okay, question number 9, refer the same. Okay, cool. How many units of labor should the firm use to produce 400 units of output with the least cost? Okay, so what I can do, I can actually, why don't we do that? Just delete everything here. Oop. Does it work? Let me see. Lasso tool. Okay, it worked. Perfect. So we are going to work on this example. Alright, so in this question, how many units of labor should the firm use to produce 400 units of output least cost? Actually, to produce the 400 units of output with the least cost, hold on, let's do the last two. Okay. Cleaning it. Okay. So what did we find, right? So far we have the information that rental rate is $50, labor is $20 each unit. Perfect. So we are trying to produce 400 units, least cost. Okay. So we're trying to find this point right here. All right. So the point is here, right here. And in the question, folks, it actually shows us the tangency point here. And I know it requires 60 units of capital. So what I'm going to do, I'm going to write down the equation for this line. And then simply what I can do is plug the value of capital to find labor. Okay. So let's do that. What I'm going to do, I'm going to write down the equation. Let's say I don't know anything. Wage times labor plus R times capital equals total cost. Remember from the previous part, so what's the question again? We are trying to find this labor. How many labor do we need? I know I need 6 units of capital. I don't know. I put a star for the best level. I don't know how many labor I need. So one method is actually using our budget line. So we can use the information we had from the previous part. C is total cost of production. This ISO cost line is $5,000. Okay. I know what R is 50. I know what K is 60. The total is, this is multiplication. Total cost is 5,000 and I have wage times labor 20L plus. Okay, so I'm going to solve for L. So what are we doing, folks? I have this equation for this line, looks like this. 20L, this is 3,000 plus 5,000 equals 5,000. I apologize. Okay. So how did I get this? This is my equation. So once I plug in the capital in this equation, you can actually solve it for labor and you would find this intercept point here. Cool. 3,000 goes to the other side. It becomes 2,000. 20L equals 2,000 divided by 20. You will find labor to be 100 units. So this here is going to be 100 units. Okay. 100 units of labor. Correct answer is A. Again, figure 8. Cool. The minimum cost of producing 800 units. Okay. So now the question is, let me go over it again. Minimum cost of producing 800 units. Okay. I'm just deleting everything. Let's see. Let us see. Oops. Okay, so using the same logic, I want to produce now this 800 units. What's the total cost? What do I know so far? R is 50. Okay, this is not hard at all. So I'm going to go to this ISO cost line, this one, and I'm going to find the value of this ISO cost line. And I'm going to use this intercept. What does this 150 mean? Okay, capital being 150. So that is actually total cost divided by rental rate is equal to your intercept, y-intercept of this budget line. But find the right budget line to produce the level of quantity you want to produce. This is 50 So 150 times 50, I believe this is $7,500, the total cost of producing this budget line. So it should be B. Next question. Which of the following, this is the last one, which of the following combinations of capital and labor lies on the expansion path? Okay. So bunch of I am just going to actually delete everything so we get there easily, because I need to see the figure. Okay, you don't do that. And this is question 11. This is not question 9. Okay. Okay, what have I done? This is, okay, let's see. Okay, question 11. Again, this is not question 9. This is 11 because I deleted them. All right. So refer to question 8. That's the original one. Which one falls in? So this is 60, right? This was 100. We found it. So this doesn't lie, right? What else? So the one with labor 120. Let's get 120. Is this 110? I don't know. This could work. 130 to 200. Okay, so let's see that actually lies on the expansion path here. Okay, 130, 175. So I'm going to see if the first one lies in the expansion path, if this one corresponds to that point. So wage rate is 20. This ISO cost, total cost here, right? This ISO cost is 7,500. We found it in the previous question. Yes. Okay, so I have all the information. So it's 20 wage rate times labor plus, what's my R? 50 times capital, 7,500. I just found the equation first. So I'm going to plug in 110 capital. And whenever I see capital, I'm going to plug this in. 20L plus 50 times 110 equals 7,500. Okay. So 50 times 110, I'm going to use a calculator. 50 times 110, 5,500. So 7,500 minus 5,500, that's $2,000. 20L, divide everything by 20. Okay, L is going to be 100. Okay, so this is wrong because if you put 110 capital, labor is supposed to be 100. Okay, next we are going to try C and D. So next it's talking about another expansion path. We're going to do that. We're going to go to that equation. Okay, so 130. Okay, let's clean everything. So here 130 capital. Okay, all right, we could do this long way. I'm going to show you, and I'm going to show you one shortcut. So this is first the long way. First we have to figure out what C is. Okay, so this is not the total cost because this is a different ISO cost curve now. Okay, so for this one, C divided by labor equals to 500, right? This intercept is C divided by, I apologize, I said labor, but the price of labor, I apologize. C divided total cost divided by price of labor wage rate is equal to 500, right? This is C over W. This is total cost over rental rate, price of capital. I know this is $20, so as a result, total cost is $10,000 here. Next step is to set up your budget line. Okay, so it is, what is the ISO cost line? I keep saying budget line, but it is ISO cost. R, it's the same thing, company's budget. C. So plug in everything, 10,000. Wage rate 20L plus 50K. Yes. Equals 10,000. So it's saying plug in 130, right? Because 130 is on this line. That's why we focused on this ISO cost. Okay. So just keep that in mind. I see 130 on this ISO cost line. So I'm going to try to focus on this ISO cost line. So it says put 130 for capital. So 50 times 130 equals 10,000, 20L. Okay. So 50 times 130. 50 times 130, 6,500. So it's $10,000 minus $6,500, 20L, $3,500, 20L. Then L is going to be $3,500 divided by 20. So let's grab our calculator. $3,500 divided by 20, 175. Okay, this is the most reliable technique. So D is the correct answer. Okay, so let's see if I can grab all the questions. Let me see. Ooh. We're undoing lots of things. I'm bringing all the questions back. Okay, so let's see if there's an easier way to handle this question. Okay, I'm just doing, all right, so let's get back to question 11. So what else can I do to handle this question? There's one more way, which is a little bit easier way. Okay, what I do, I use the slope formula and the triangle, right? So what's the slope of this budget line? Slope of this budget line. Slope is always negative wage rate over R. Okay, so it's 20, 50. It's going to be what? Negative 0.4. Okay, so the proportion will always be 4 to 10. Okay, so it's, remember, rise over run. So if this is 4 units, this is going to be 10 units. So that's another I know it's a little bit convoluted, but let's try if it works. Okay, so this is from 130 to 200 is 70 units. So I can technically find from here, origin to here, which is the run part. Okay, if this is 70 units, let me use a different color. I'm using a very shortcut technique. You don't have to, just follow the formula. So this is 70, then what is this? So if 4 rise, 10 run, if this is 70 in rise, what is this, right? Okay, so you can do this multiplication. 700 divided by 4. Okay, so 700 divided by 4, 175. You got this in easy way. Okay, so this technique, basically we use the formula of a triangle and the slope formula.